Welcome, dear students. Now we shall discuss about the session number 35, in which we are going to study IDFT, inverse DFT, inverse discrete Fourier transform, and also periodicity, periodicity of DFT, that is x of k, and inverse DFT, that is x of n. So in session number 35, we are going to discuss the definition of inverse DFT and periodicity of DFT and IDFT. So in the session number 34, that is last session, we have studied what is meant by DFT. So DFT, discrete Fourier transform, once again I will define it. If x of n is a continuous time signal function, then DFT of this continuous time signal function is nothing but getting samples. N equals 0, 1, 2, 3, etc. are the number of samples. Getting the samples of this continuous function is called DFT. And this DFT is represented by x of k. Okay, therefore, if this is a continuous time signal function, then samples of that functions is represented by x of k is called DFT of this continuous function. And also, all the samples are equally spaced. The distance between two samples is same. So DFT is getting the samples. These are all the samples. Getting the samples of continuous function x of n. And mathematically we express DFT as x of k is the DFT of small letter x of n. X of n is continuous time signal function. Capital X of k is DFT. Then DFT of x of n is defined by x of k equals sigma n equals 0 to n minus 1 into x of n into wn nk. Here k is number of samples. For n point DFT, k can have n number of samples. Therefore, 0 less than or equal to k less than or equal to n minus 1. This is the mathematical expression for DFT. Then what is IDFT? Inverse DFT. Inverse DFT is the reverse process. That is, if you will be given a number of samples, you can get a continuous time signal function x of n. So if x of k is the DFT, that is number of samples, then by knowing that number of samples, you can get the continuous time signal function x of n. That is called inverse DFT. And mathematically we express inverse DFT as x of n. So if capital X of k represents DFT, then small letter x of n represents inverse DFT. Then inverse DFT x of n is equal to sigma x of k. Now k equals 0 to n minus 1 wn minus nk divided by n. Here n can have values n number of samples. Therefore, 0 less than or equal to n is less than or equal to n minus 1. This is the definition of inverse DFT. See the expression capital X of k represents DFT of this function x of n, which is given by sigma n equals 0 to n minus 1 x of n wn plus nk. Here x of n is represented as inverse DFT of the DFT function x of k. The inverse DFT x of n is equal to sigma k equals 0 to n minus 1 x of k wn minus nk divided by n. Here it is plus nk represents DFT, minus nk represents IDFT. In general, we can write like this: DFT of x of n is x of k. and IDFT of x of k is equal to x of n. So x of k is nothing but DFT of x of n, and small letter x of n is nothing but IDFT of x of k. Now we will discuss periodicity of x of k. What is periodicity of x of k? It is periodicity of DFT of a given function. Before deriving this expression, I will give you some examples with samples. Now, consider the samples like this. This is 0 sample, the first sample, second sample, third sample, fourth sample, fifth sample, sixth sample, seventh sample. So total number of samples is 1, 2, 3, 4, 5, 6, 7, 8. Including 0, there are 8 number of samples. Therefore, I will write the 8 point DFT. N is equal to 8, where N represents number of samples. Now, periodicity means let this given function be a total length of 2 pi. After 2 pi, the same function repeats, because periodicity means the function repeats periodically. In the period of 0 to 2 pi, you have n number of samples, that is 8 samples given by these values. And after 2 pi to another 2 pi, next for 2 pi, that is from 2 pi to 4 pi. This is 0, this is 2 pi to 4 pi. You will get the same samples. That is, 8th sample is 0. Write the same sample 1, 2, 3, 4, 5, 6, and 7. This is 8th sample. 8th sample, this is 7th sample, this is 8th sample, this is 9th sample, 10th, 11th, 12th, 13th, 14 and 15. See, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 samples in the period range of 2 pi. For the next to 2 pi, that is from 2 pi to 4 pi, for the same period range 2 pi, again you have 8 samples. 1, 2, 3, 4, 5, 6, 7, 8. That is sample number 8, 9, 10, 11, 12, 13, 14, 15. Now what is periodicity? Here in the period 2 pi, there are 8 samples. Now 0 sample is nothing but 8th sample. First sample is nothing but 9th sample. Second sample is nothing but 10th sample. See the height. Third sample height is equal to 11th sample height. Therefore, 11th sample is nothing but third sample. This third sample can be written as 8 plus 3. 11th sample is equal to 8 plus 3, which is equal to number of samples 3 itself. Then what is the 14th sample? 14th sample is 14 minus 8 is equal to 6. 6th sample is something but 14. How do you write this 14? 8 plus 6 is equal to 14. So 14th sample is nothing but 6th sample. So I will write in each steps. 8th sample. So 8th sample is nothing but 0 sample. Therefore 8 is equal 8 plus 0. Next, 9th sample is nothing but 8 plus 1. Next, 1 sample. 10th sample is nothing but 8 plus 2 is 10. So 10th sample is also nothing but sample number 2. 11th sample is nothing but 8 plus 3. It is equal to third sample. 12th sample is equal to 8 plus 4. It is equal to 4th sample. So 12th sample is similar to 4th sample. Similarly, 15th sample. 15th means 8 plus 7. So 15th means 15th sample is also equal to 7th sample. So this is 8 point DFT. After 8 point, same value repeats. Therefore, 8th sample is nothing but 0 sample. 9th sample is nothing but first sample. 10th sample is nothing but second sample. Therefore, you need to derive only 8 point DFT. And 9, 10, 11, 10 need not to be derived because they are same as before. So in general we can write, if there are n number of samples, n plus k is equal to k itself. So this is called periodicity of x of k. That is, each sample repeats periodically. Now we will derive it mathematically. So to prove periodicity of x of k, consider x of n plus k. We have to show that x of n plus k is equal to x of k itself. So x of n plus k is equal to x of k itself. After n point, same sample is repeated. Therefore, x of n plus k is equal to x of k itself. This is periodicity of x of k. By definition, what is x of k? X of k is nothing but sigma n is equal to 0 to n minus 1 x of n w n n k, where 0 is less than or equal to k less than or equal to n minus 1. So x of k is the DFT of x of n, which is given by x of k equals sigma n equals 0 to n minus 1 x of n w n n k. Now consider x of k plus n, which is equal to sigma n is equal to 0 to n minus 1. So wherever k, put k plus n in this equation. This is x of n is as it is. W n capital, small to the power small n, k. Instead of k, put k plus n. This is k plus n, which is equal to sigma n equals 0 to n minus 1 x of n. Split the indices. You can split this like this, wn n k into wn n small letter n capital letter n into n, which is equal to sigma n equals 0 to n minus 1 x of n wn to the power of nk into wn to the power of same n, capital N to the power of capital N multiplied by anything, which is 1 itself. Therefore, finally we can write this as sigma n equals 0 to n minus 1 x of n wn nk. By definition, what is this? Sigma n equals 0 to n minus 1 x of n wn nk is the DFT of x of k. See, sigma n equals 0 to n minus 1 x of n wn nk is equal to x of k DFT. Therefore, sigma n equals 0 to n minus 1 x of n wn nk is nothing but capital X of k. Here the left side is x of k plus n, which is equal to x of k right side. This shows that x of k is a periodic function. Now we have to prove this. Wn to the power of nn should be 1. Let us prove how it is. Consider Wn. What is Wn? Wn is e to the power of minus j 2 pi by n. by definition Wn. Therefore, Wn to the power of nk to the power of nn is equal to exponential minus j2 by n to the power of nn. Here capital N get cancelled, which is equal to e to the power of minus j 2 pi into small n. We know that e to the power of minus j theta, if this is an angle theta, e to the power of minus j theta is cos theta minus j sin theta. Therefore, you can express this as cos of 2 pi n minus j sin of 2 pi n. We know that cos 2 pi n is 1 minus j sin 2 pi n is 0, which is equal to 1. So, it is to be noted that Wn to the power of same n multiplied by anything is 1. Similarly, W4, so 2 into 4, W4, therefore it is 1. Similarly, W5, 2 into 5, what is this value? W5, same 5, which is 1. Similarly, W8, that is 16. Let us consider 16, which is equal to W8, 2 into 8. 16 means 2 into 8. W8, same, multiplied by anything, of course, which is equal to 1 itself. Similarly, it is also equal to W8, 3 into 8, W24. 8 into 8 is, therefore it is 1. So you have to remember that W of n point multiplied with the same n point power is equal to 1. Let this n may be multiplied by any value k. It is 1. Therefore, x of k plus n is equal to x of k. This is the periodicity of x of k. Thus, it repeats in general for n point DFT. For 8 point DFT, what is the 10th sample? X of 10 is equal to x of 8 plus 2, which is equal to x of 2 itself, because by definition x of n plus k equals x of k. Here k is 2, n is 8, because we are considering 8 point DFT. When n is equal to 8, you can write this as x of n plus k, which is equal to x of k. So, 10th sample can be written as 8 plus 2. Since it repeats after 8th sample, x of 8 plus 2 is x of 2. Similarly, what is the sample of x of 14th sample? The 14th sample of 8 point DFT. The 14th sample of 8 point DFT is also equal to x of 8 plus 6, which is equal to x of 6. What is the 5th point DFT of 14th sample? 5th point DFT of 14th sample is equal to f of 14 can be written as 9, 5 plus 9. So n plus k is 9, which is equal to x of 9 of 1. Again, x of 9 can be split. X of 5 of 9 is equal to x of 5 plus 4. X of 5 plus 4 is x of 4 itself. Therefore, x of 14th of 5th DFT point is x of 4 itself. This is how you have to find the higher samples. The higher samples are calculated using n plus k. So, x of n plus k is equal to x of k. Now, let us derive or let us show the periodicity of inverse DFT, that is x of n. That is, we have to show that x of n plus n is equal to x of n. This is the periodicity of x of n. What is small x of n? IDFT, inverse DFT of capital X of k. So by definition, we know that x of n is equal to sigma k equals 0 to n minus 1 x of k wn minus nk divided by n. I will write divided by n as 1 by n here. So this is the definition of IDFT. If x of k is the DFT and x of n is the IDFT, by definition x of n is equal to 1 by n sigma k equals 0 to n minus 1 x of k wn minus nk. Here k equals 0 to n minus 1, having n number of samples. Therefore, the small letter can also have n number of samples. 0 is less than or equal to n is less than or equal to n minus 1. Let us prove this x of n plus n is equal to x of n. Consider x of n plus n. Consider x of n plus n. So, by definition of inverse DFT, x of n plus n is equal to 1 by n sigma k equals 0 to n minus 1 x of k into wn to the power of minus, put n plus n whenever there is a n. Here it is n, here it is n. Here it is n plus n. Therefore, this is power n plus n into k, which is equal to 1 by n sigma k equals 0 to n minus 1 x of k. Split the indices wn minus nk minus n into k into wn minus capital N into k minus capital N into k. But we know that wn of n multiplied by either plus or minus k, wn to the power of same n is always 1. We have already proved. So we know that wn to the power of n multiplied by anything is 1. Here it is wn to the power of same n multiplied by minus k. It is 1. Since this is 1, you get x of n plus n, left hand side x of n plus n is equal to 1 by n sigma k equals 0 to n minus 1 x of k wn minus nk. Wn to the power of n, same value is 1. But what is this? So 1 by n sigma k equals 0 to n minus 1 x of k wn minus nk. See here. 1 by n sigma k equals 0 to n minus 1 x of k wn minus nk is nothing but x of n. Therefore, x of n plus n is equal to, this is nothing but x of n. So this proves the periodicity of x of n. So periodicity of x of n, for example, x of 8th point DFT I will consider. 8th point IDFT I will consider because x is IDFT. 8th point IDFT. So is 8 plus k, which is equal to x of k. Here instead of k, 8 point, I will write 8 point is x of n. Example, x of 8. What is the 14th sample? 14th inverse DFT of 8 point IDFT. 14 samples of 8th point IDFT is x of 8, 14 is x of 8, 8 plus 6, which is equal to x of 8, 6. Similarly, x of 5 of 14. What is this sample? 14th sample of 5 point inverse DFT is also is equal to x of 5. 14 can be written as 5 plus 9. By definition, it is x of 5, 9. Again, this is more than 9. You can take this as x of 5. 9 is nothing but 4 plus 5. Which is equal to x of 5. Therefore, x of 8th. See, x of 8th. 14 is x of 8. 8 plus 6 equals x of 8 into 6. Similarly, x of 5th point IDFT. 14th samples of 5th point IDFT is equal to 5 point IDFT x of 5. 14th can be written as 5 plus 9. By definition, it is x of 9. Again, 9 is more than 5. You can write this as x of x5, 5 point DFT. So 5 plus 4, that is 4 plus 5. So it is x of 4 itself. So this proves the periodicity of x of k and x of n. Thank you.